It is the 28th of June 1983, and a truck trailer is hanging rather precariously in the air. Its bizarre location was caused by a regular in this channel, a bridge disaster. In the early hours of the morning, a section of the bridge over the Mianus River just randomly fell off, but the truck trailer was just the tip of the iceberg of destruction, as another truck and two cars had also smashed into the water below. But what was the cause? Well, that's what we will find out in this short dive, excuse the pun, into the Mianus River bridge disaster. My name is John and welcome to Plainly Difficult. This video wouldn't have been possible if it wasn't for my Patreon, YouTube and Ko-fi members. Their financial support really helps keep the lights on. In exchange, I offer ad-free early access to all of my videos, and at some tiers you even get your lovely name right here at the start of my videos. The bridge. Our story starts in the 1950s with the construction of a new interstate road, the I-95. This is the highway along the east coast of the United States. Like all long road projects, rather a large amount of infrastructure was required to facilitate the smooth flow of traffic. One such piece was across the Mianus River in the state of Connecticut. The bridge to span the crossing was designed in 1955 to standards set out in 1953 for highway bridge design. It was completed in 1958, just in time for the I-95's opening. The bridge was a deck bridge design, where the road deck sits above the superstructure. It was over 2,600 feet long and was 70 feet above the river. The bridge had 2 abutments and 23 piers, which holds up 24 bridge spans, of which there were 19 approach spans, 2 anchor, 2 suspended spans and 1 main span. The majority of the approach spans were on the west, and I'll miss them out for this diagram for brevity, and also the reference diagram I was using from the NTSB report doesn't show them as well. So the piers were reinforced concrete in which the spans were mounted. Now each roadway spans were constructed of 2 parallel steel girders. I should say that the bridge was kind of technically 2 parallel bridges, as both roadways are independent of one another. Anywho, these 2 parallel steel girders have floor beams attaching them together, with stringer beams running into the floor beams. The suspended spans, which covered 2 sections of the bridge, were split into 4 individual spans, due to the whole parallel bridge shenanigans. They are attached to the bridge on one end by a cantilever section, part of the anchor spans, and at the other end attached to a cantilever section attached to the main span. The suspended spans are attached to their respective cantilever sections via a pin and hanger arrangement. The pins were 7 inches long with a diameter of 7 inches as well. They are inserted into the girders of the suspended spans and their respective anchor spans and cantilever sections. Covering over this is the inside and outside hangers, which help carry the load. The caps are held in place by a bolt that is inserted into the pin and secured with a nut and washer. The sections had an expansion joint with interlocking fingers on the roadway. Below this was a copper drainage channel. This is a very oversimplified explanation, but like all intricate steelwork, especially like this, it can be susceptible to corrosion if not properly protected and maintained. Part of this protection is with proper drainage, and the bridge had this in that there were gratings along the roadside curbs. This led water down towards downspurts, which allowed the water to be safely drained off into the river. Now these suspended spans are skewed at an angle when looking down straight at them, so the bridge follows the Mianus River channel below. Now the bridge, post-opening, saw good use as it carried the traffic along the I-95, well, until it stopped doing that. The disaster. It is the early hours of the 28th of June 1983, and traffic across the Mianus Bridge is understandably light. Heading eastbound is 2 articulated lorries and a car. One of the lorries are on the curbside lane and the other is in the middle lane, and the car is in the median lane. Suddenly at 1:30 in the morning, the highway lighting went black as darkness hit A following car saw the taillights of one of the trucks disappear. The next truck started jackknifing, followed by the tractor unit plunging over the edge. The trailer, eventually smashing into the ground, was left sitting rear end up. The 3 vehicles, the car and 2 trucks, had plunged down the some 70 feet drop below. The following car managed to stop. The 2 occupants escaped, seeing the now empty space of the bridge. They tried to warn other road users approaching on the eastbound roadway. Their efforts unfortunately were in vain as another car launched off into the void. A some 100-foot span had magically appeared and dropped into the river on the eastmost suspended section of the bridge. Quickly, emergency services were called by locals hearing the commotion from nearby Greenwich, and no, not that Greenwich. The Marine Police and the United States Coast Guard were notified and attended waterside, while Greenwich Police blocked off the I-95 at the bridge, creating a rather long and arduous diversion for road users. The crashed vehicles were examined by emergency services and 3 bodies would be removed. This was the driver of the first truck, a passenger in the first car, and the driver of the second car. Amazingly, the drivers of the first car and second truck survived, albeit with very severe injuries. The bridge would remain closed until September 1983, pushing some 90,000 daily road users into local roads. A temporary fix was made via a truss section installed to the bridge to bridge the gap. Of course, after the remaining structure was examined, and we'll come to that in a little bit. Eventually, the bridge was rebuilt almost entirely. The piers, although fully refurbished, are pretty much the only thing that remains. Everything else is new, well, at least new in the late 1980s and early 1990s when it was rebuilt. The bridge was given a new name, the Michael L. Morano Bridge, after the local senator. But of course, what we really want to know is what was the cause of the accident. The investigation. So, as a US transport-based disaster, it would require a long-term good friend of the channel, the NTSB. Post-accident, the bridge was inspected and it was discovered that 2 of the 3 remaining suspended spans each had some form of misalignment. In some places, over a half of inch of movement had occurred. The failed portion of the bridge had evidence of its beginnings in the southeast portion and its pin and hanger assembly. Inspection on the eastbound span on the other end of the bridge revealed a considerable amount of corrosion on the outer pin and hanger assembly, and after being relieved of its load and disassembled, large amounts of black rusty water had flowed out. This seemingly was not visible with the assembly in place, albeit just for a few brown surface rust spots. It would seem likely that the failed eastbound span on the eastern side would have experienced a similar effect. Interestingly, the northern side of the bridge didn't experience the same level of corrosion. So why then? Inspectors had checked the bridge's drainage system, and guess what? The curb on the southern side was covered with debris, with even weeds emerging, sprouting through. It would turn out that the bridge's drainage channels had 10 years before been covered over with steel plates for road resurfacing. But after the work was complete, these plates weren't removed, thus severely reducing the ability for water to be shed away from the vulnerable pin and hanger joints. The NTSB set out their theory of the bridge's failure, beginning in the inside hanger. Over the years, it had become displaced and separated from the lower pin. This allowed corrosion to form within the assembly. Now only resting on one pin, it was only a matter of time before failure. Once the inside hanger had failed, the southeast corner was now solely supported from the outside hanger. Soon after, the outside hanger too slipped off the upper pin. The span was now only supported on 3 sides. Deflection of the suspended span caused it to twist. Next, the southwest corner failed, followed by the northwest, then complete collapse. Interestingly, the corrosion was the cause of the inner hanger failure, but for not how you might think. It was from the pressure caused by the formation of rust between 4,000 and 7,000 psi. This was the cause of the bending action that broke the vital hanger. This corrosion was not picked up during inspections of the bridge, which then, when coupled with improper drainage, well, we can see the results. It's quite crazy to think. The NTSB would summarise this in their report. The National Transportation Safety Board determines that the probable cause of the collapse of the Mianus Bridge span was undetected lateral displacement of the hangers of the pin and hanger assembly in the southeast core of the span by corrosion-induced forces due to deficiencies in the state of Connecticut's Bridge Safety Inspection and Bridge Maintenance Program. Now, across the state, bridges would be modified to remove this type of pin and hanger assembly system, as well as more stringent inspections, gutter cleaning and general maintenance. The state would be hit in 1986 with a settlement for the bridge's victims, as stated in the Associated Press. The state has reached an out-of-court settlement worth almost $6.3 million, with 4 of the 6 victims of the 1983 collapse of the Mianus River Bridge on the Connecticut Turnpike. Which is hardly a surprise, as it was the state's fault. Now, it's scale time. I think it's going to be a 3. Do you agree? And this is what I've got for my root cause analysis card. This is a Plain Difficult production. All videos on the channel are Creative Commons Attribution Share Alike licensed. Plain Difficult videos are produced by me, John, in the currently cold and not so sunny corner of southern London, UK. And all that's left to say is thank you very much for watching, and Mr. Music, play us out please.